Hi Calc BC friends! Today we're going to look at the 2015 Calc BC FRQ number 6. So this is a pretty standard Taylor series, Maclaurin series question, and here's a series they give you which represents the function f. So the first part of this would be to find the ratio test to find r, which is a radius of convergence. And as we can see, this is an alternating series. So if we were to rewrite this series as an alternating series, we could just pull out the -1 to the n minus 1. And see that it looks like this. And when you use the ratio test, you find the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. So in this case, because there's absolute value bars, we don't pay attention to the alternating part and we just look at the rest of the series. So let's just write this out. So limit as n goes to infinity of a sub n plus 1 is, you just put n plus 1 where there's n. So there's 3 to the n plus 1 minus 1 is n over n plus 1 times x to the n plus 1. And then you divide it by the original series, but instead of doing that, you can also multiply it by the reciprocal, which is the same thing. And you just put the x sub n on the bottom, the 3 to the n minus 1 on the bottom, and the n on top. Well, that does not look like an easy limit, but we can cancel out things by rewriting it. For example, 3 to the n is the same thing as 3 times 3 to the n minus 1, because 3 n minus 1 plus the 1 here is n over n plus 1 times x to the n plus 1 also equals x to the n times x. And then multiply that. Just rewrite those. And we'll see that now a lot of these terms will cancel out. And what we're left with is the limit as n goes to infinity of absolute value of 3x times n over n plus 1. And because we took honors pre-calc, we know that the limit as n goes to infinity for n over n plus 1 is just 1. So this is the same thing as the absolute value of 3x. And the ratio test tells us that this must be less than 1 for this series to converge. And because 3 is a positive constant, we can pull it out of the absolute value. And then we'll have the absolute value of x is less than 1/3. And that means our radius of convergence is also 1/3. Nice. Part B asks for the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of x. Well, we already have 3 terms of the polynomial that represents f, but we need 4 terms. So this is the first term where n equals 1 because it starts at 1. This is the second, third, and let's see if we can find the 4th term for f of x. So it's when n equals 4, right? So 4 minus 3, 4 minus 1 is 3, -1 to the 3rd power is still negative. 3 cubed is 27 over n, which is 4 times x to the 4th. And this is the first couple terms of f of x. So then the first couple of terms of f prime of x would be 1 minus 3x plus 9x squared minus 27x cubed, and so on. These are the first 4 terms. Oops, that's cubed. And now they ask for you to express f prime as a rational function for, the radius of convergence. So rational functions are just functions in the form of a fraction. And that kind of gives us a hint, because we know that the sum of a geometric series has the form a over 1 minus r. And hey, look, this is a geometric series, and r is -3x. So every time you multiply by -3x. And this is a series, so to find the sum of it, use this. A is the first term, so 1 over 1 minus r is 1 minus -3x, so 1 plus 3x. And this is actually the function that represents f prime of x. Okay. Part C asks for you to write the first 4 non-zero terms of the Maclaurin series for e to the x. Well, you should probably just have that memorized by now, and if you don't, go memorize it, because it's important. You should memorize this one and also the other basic ones, like sine and cosine and ln and stuff like that. And they ask for the first 4 non-zero terms. Well, that's fine, because none of the terms are really 0. Or else you could just write 0 plus 0 plus 0 plus 0. Okay, here are the first 4 terms. Yes, I can count. And now they want you to use the Maclaurin series for e to the x, which is this, to write the third degree Taylor polynomial for g of x, which is e to the x times f of x, about x equals 0. About x equals 0 just means it's the Maclaurin series. So we already have some terms of f, so we can just write this out, and they want you to find the product. So literally just write out terms and distribute them and multiply them. Oh, yeah, there's some more terms, but we don't really need to think about those right now, because the reason we don't have to think about it is because they ask for the third degree polynomial, which means that the biggest power in your answer should be 3, and you can just ignore all the higher powers in that. And let's just multiply this through. So 1 times all that, 1 minus 3 halves x squared plus 3x cubed, and plus x squared minus 3 half x cubed, and they can do 3x fourth, but you don't really need that because you just need a third degree polynomial. So then let's move on to x squared over 2. So plus x squared over 2 times x is x cubed over 2, and after that you just get higher degrees. So now you just have to simplify, and I guess you don't really even need to, because on the AP test you don't need to do that, but just group your terms and you'll get 2x cubed minus 1/2 x squared plus x. And yeah, those are that's your third degree Taylor polynomial for g of x, which is e of x e to the x times our original function f. Okay, so I hope that was helpful, and if it wasn't, well, I will put more practice problems in the video description for you to do, and good luck. Goodbye.